I'm going to start off and answer the very important questions. First, I did tie the bow tie. Secondly, I wear it because a bow tie is never perfect. And certainly data is never perfect. I'm never perfect. And as we talk to this sustainability, it's important to understand you can find examples for absolutely anything to support any case. Everything in this is either derived from direct data, or where I'm displaying something that's talking about the usage or energy consumption, they're averages. So the IBM tape team sat down and said, hey, we're going to do a high level, very usable sustainability on tape, and then we'll be able to do compares with the rest of the industry, because nearly everybody reports on this, or we have open data. This is how it's laid out. I'm not going to go through every single slide and every single aspect, but here are the high levels. We broke them down into things like raw material extraction, material manufacturing, supplier transportation, and we kept it at the component level. We saw Brad John's report. This is the LTO8 with 0.007 metric tons of CO2e being emitted. Why? Most of it means there's no electricity associated with these. Very little. We've got cooling, we've got airflow effects, but when the data's sitting there, it's just sitting there. I mean, the media and entertainment industry will speak to that and say, look, when we put it on the shelf, it just stays there as long as we can possibly keep it, and then we may have to migrate it. So very low impact, even 1,000 cartridges, you're at 7 metric tons for 30 years. 7 metric tons for 30 years. Let's start off with LTO full high. Everybody knows LTO full high. It's easy to reference. 1.4 metric tons of CO2e. By the way, none of this data includes offsets for recycling. So that bottom number, you still get to recycle what's in the drive. And there's very little e-waste outside of the card. The steel, the aluminum, all of those pieces can be recycled. What drives this? An average life cycle of 6.85 years. So give or take 7 years based on all the data. Now, we can't operate a tape drive really without a library. So a TS4500, IBM's premier scale-out library, has all these components in it. Drive mounts, assemblies, LEDs, computer interfaces, and has a huge weight because it's got a whole lot of plastic and steel in it. But in a 16.4 year average life cycle, I just want to repeat that, in 17 years, even in that life cycle, you're only expending 50 metric tons of CO2e. And we can break that down into drive frames, which are more drives and more storage. Could call it a storage and performance pod. It's only 14.4 metric tons. It doesn't have a accessor or a robot in it. It doesn't have the brains, the computer interfaces that are required. It simply is a power supply and a whole bunch of slots for drives and cartridges. 14.4. And an S frame, even lower. But it's not much lower, even though it doesn't use any energy consumption. And the reason for that is, man, that thing's got 1,300 plastic cells in it. And plastic is highly caustic in its production. And when we compare this, how do we compare? Well, we've got to bring forward some comparable amount. We're going to start with 28 petabytes. Okay? Real easy number for me to do. And we're going to use the Bryce Canyon. All right, my OCP people know all about that. If you're deploying an OCP in your environment, it's a good measurement because I can go out and get all the specs. I know exactly what's in this box and how it's going to be deployed with 18 terabyte drives. If I keep 28 petabytes of data for 10 years at 11 nines of data durability using erasure coding, it's going to cost the environment 1,954 metric tons of CO2e just to keep that data around. And if these are archives, wow. How impacting is that when you compare it to IBM's latest delivery in tape automation at 78.1. 78.1 metric tons. Easy compare. What does that mean? If you moved 28 petabytes of data off of HDD and onto tape, you would be able to power 10 households for a year every single year you kept that 28 petabytes of data. Every single year you kept that data. So that's a lot of energy. How much? Give or take, 146,000 kilowatts for 28 petabytes of data with an OCP deep solution, or tape at around 7,098 kilowatt hours for the entire year, right? Huge difference. I do this compare, again, not as it's flash versus tape, but as let's look at the sustainability of these solutions. Even with a very small 500 terabytes, at least in the tape world, that's very small, which is one little stackable. For those of you who have like a TS4300 or a 3U stackable, that's all that is. It's not even a full one with LTO9. Keep that data for 10 years, anticipate that you're going to roll it at 5.2 years, 46.7 metric tons of CO2e versus 14.8 CO metric tons. So again, even at the lowest amounts, your contribution and the offsets that you may have to do let you lead with something that's very low. If you're measuring PUE, what does this do to the PUE? You instantly go, well, I have this example of 146,000 versus 7,000. Wow, I could really change my PUE. Does it mean I have to set expectations? Yes. Does it mean that data now lives somewhere where it's more archived? Absolutely. But do you really need your third copy of HDD to be on HDD? Or could it all just go to tape?